Exercise 1.32. Prove that intervals of the form a to b, including the left endpoint a, are closed in the lower limit topology on the real numbers. Now you remember that intervals of this form are precisely the basis elements for this lower limit topology. So in particular, that they are open sets in that topology, and we're about to prove that these open sets are also closed. Okay? So to prove that they're closed, as always, we need to show that the complement is open, right? That R minus the interval from a to b, which is the interval from negative infinity to a, union the interval from b to infinity, including b, is open. Okay? So let's get an idea of what to do by drawing a picture. We'll begin with a real number line and our given interval from a to b. And we need to prove that the complement is open. So this piece over here, this piece over here. And we're going to do that by showing that, excuse me, showing that each of those pieces is a union of basis elements. Okay. So as for this one over here, well, we can sort of build it up step by step. So we could have the interval from a minus 1 to a. So we start out with these points, and then we could move the left endpoint over a bit to a minus 2, and have the interval from a minus 2 to a. And then we can take the union of those with the interval from a minus 3 to a, and so on, and you just keep going, and eventually you get everything, all the negative real numbers, right? Everything down to negative infinity. Okay. So that's a union of base elements, therefore it's open. And you can do a similar thing on the right side here. We can start off with the interval from b up to b plus 1, which is a base element, and then take the union of that with the base element from b up to b plus 2, and so on, b plus 3, b plus 4, and eventually we get everything from b up to infinity, including the b. Okay, so that's pretty much the proof. Let's just try and write that out in symbols. So let's see, we have, let me copy the complement. Right, there it is, and it's equal to, well, the first interval is the union from 1 up to infinity of interval from a minus n to a. Okay. And then we want to take the union of that with the union from n equals 1 to infinity of the interval from b to b plus n. Okay. And that's a union basis elements. Okay. Hence, it's open. And that does it.